Welcome back, candidates. In this module, we're going to be looking at compounding and discounting cash flows. So you're going to need your BA2 plus calculator. Remember, only two types of calculators allowed in the exam, the BA2 pluses and the HP12C. These are the BA2 pluses. This is what they look like, either the standard or professional. It doesn't really matter which one you use. They've both got plenty of functionality for the exam. The other type of calculator you can use in your exam is the HP12C. Now, we recommend the BA2 Plus because, well, number one, it works as you'd expect a calculator to work. It's cheaper. It's got more functionality for the CFA exams. The HP12C uses a method called reverse Polish to enter data. So what I would say here is, unless you've used it before, don't use the HP12C. It uses reverse Polish. It's got less functionality. And it's more expensive as well. So Texas Instruments are the calculators that we will support in the videos. Right, okay, so go grab a calculator and then we'll jump into the first learning outcomes statement. So our first learning outcome statement here says calculate, interpret and demonstrate future values and present values for single amounts, annuities and unequal cash flows. Now we're going to start off by looking at the future value of a single sum, and this is what we refer to as compounding. So it says, what is the future value of $200 invested today for 2 years or 2 years from now if the interest rate is 10%? So what will we receive at the end of the second year? Now what we could do is take that $200, multiply by 1.1, which would give us $220 at the end of the first year, multiply by 1.1 again, and that will give us $242 at the end of the second year. So notice 1 plus 1 that I've used here is 1 plus R, where R is our interest rate expressed as a decimal, so 0.1. Okay, so that's absolutely valid to do it that way and get your 242 that way. Probably a little easier than that is to do 200 times 1.1 squared, okay, to get 242. And I'll show you how to do that on the BA2 Plus calculator. So let's get my BA2 Plus up on screen. There it is. Now, before we launch into computations, we need to make a few adjustments to our BA2 Plus. First of all is to the number of decimal points. You can see my calculator out of the box says 0.00, so it's defaulting to 2 decimal places. And that's just not going to be enough for accuracy in our CFA exams. So when you've got your calculator, press second function and the decimal point button. And there you go. You can see it's telling me I'm set to 2 decimal points. I'm going to choose 9 decimal points. So type 9 and you must press the enter button. See a little equals appears when you press that enter button. Now, if I clear my calculator off by pressing clear equals cancel a couple of times, you'll see the decimal points disappear. What it will now do is it will give me up to 9 decimal points depending on my computation. So let's just check that. 4 divide by 3. And there you go. You can see up to 9 decimal points appearing on the screen. Now, the other thing you just need to briefly check on your calculator is how many compounding periods per year or discounting periods per year. It should automatically default to 1, but if you're having any trouble with computations, just check this. Do second function and IY, and PY appears on your screen, and that just tells you how many payments per year the calculator is defaulting to. You want to see 1 here. If you're seeing anything else, just type 1, press the enter key, and you're good to go. Okay, so I'm now good to go on my BA2 Plus. So I want to do 200 times 1.1 squared. To do this, I'm going to do 1.1. So 1 plus my interest rate as a decimal. I'm going to hit the Y to the X button, that's my power of button, and press 2. And that gives me 1.21, which is just 1.1 squared. And then finally, multiply by my present value, 200. And there you go. My future value is $242. Now, the other way of doing this is to use your time value of money buttons. Now, notice when we use our time value of money buttons, we're going to use N equals 2 because we're compounding for 2 periods. We enter our discount rate, IY, as 10. Now, be careful here. We enter it as a full number, not as a decimal. If you enter it as a decimal, you're going to get a really strange answer from your BA2 Plus. It's just the way it was built, okay? So it wants interest rates as whole numbers, so 10. Our present value is 200. Payment equals 0. We'll talk more about payment in a second. and we're going to compute future value, and you get minus 242. Right, let me bring up my BA2 plus, and we'll do the computation. Now, before I use my time value of money buttons, the third row, I'm always going to do second function future value. And you can see above that button, it says clear time value of money. In other words, it strips out any data previously stored on these buttons. Simply turning your calculator off and on again will not do this. Okay, so you need to be used to just doing second function clear time value of money. Otherwise, you might find that your calculator picks up data that's been stored on a button from a previous computation, okay, and builds it into your calculation, and you're wondering why you're not getting the right answers. Okay, so I now need to enter N, IY, and present value. I can enter them in any order, okay, it really doesn't matter. I'll do it in the same order that it's given here. So you type 2 for 2 periods, and then you hit the N button. 10, and the IY button. 200 as the present value, and the PV button. Now, I don't need to enter anything on the payment button, provided I've cleared all those time value of money buttons to 0. Okay, it already has 0 stored on it. If you didn't do clear time value of money, you would need to type 0 and then payment to overwrite whatever's stored on it. Now all I'm going to do is press compute and future value, and there you get the minus 242. Now you might be asking yourself, why does the calculator show minuses for the future value? Well, it's because we entered the present value as plus 200. So we're treating the present value here as an inflow. So if we had an inflow of 200, maybe you borrowed $200, you would have to pay out $242 in 2 years' time. Now notice, if I treated the present value as an outflow, so if I type 200 negative, plus minus button negative, and store that on present value, I'm now saying I pay out $200 at T0. So if I compute the future value, notice it's positive. So really, I always say outflows from an investor point of view are treated as negatives, inflows as positives. So I'd be more comfortable treating this as minus 200 and getting a future value as positive 200. Given if I'm investing, I've got an outflow, and then 2 years later, I've got an inflow. Okay, doesn't really matter what order you do them as long as you're consistent with your cash flows. So that's the future value of a single sum. So now let's turn our attention to the present value of a single sum. Now these computations are going to be critical because remember in the previous module we said we can view the intrinsic value, the theoretical value of a security, as the present value of the future cash flows it generates discounted at the investor's required return. So we're going to need to know how to compute present values. So present value, of course, is just the T0 value of a future cash flow given a required return. So this time we're receiving $200 in 2 years, and we're asked what is it worth to us today. So you could simply divide by 1.1 plus your interest rate as a decimal for 1 year, okay, and then divide it by 1.1 again, okay. Let's do that. So 200 divide by 1.1, that gives us 181.82. So this value here, I'm going to round to 2 decimal places just for speed. Divide it by 1.1 again, and we get, oh, that's not right, 181.82 divide by 1.1. Okay, and I get 165.29. Okay, so $200 received in 2 years' time is the equivalent of $165.29 today if our investor requires 10%. Or if you like, an investor would be indifferent between receiving $165.29 today or $200 in 2 years' time if they required a return of 10%. Now again, we can speed that up a little bit by, rather than dividing by 1.1 twice, we can say take the future value and multiply by 1 over 1.1 squared. Okay. Which this is just saying multiply by 1 over 1 plus r to the power of n, where n is the number of periods you're looking at. That is known as a discount factor. So let's start by doing that. I'll show you how to do it on the calculator. So let me just get my calculator up. There it is. So I'm just going to clear my calculator and start with 1.1. So I'm going to start with the 1.1, raise it to the power of 2, and that gives me 1.21. Okay. Now we want 1 over 1.21, and I can get that by hitting my 1 to the x button, the reciprocal button, which now gives me 0.826. That is a discount factor. Take a future cash flow, multiply by a discount factor, you get the present value. So if I now multiply by 200, there you go, there's the 165.29. Okay, so $200 at T0 is worth 165.29. Notice they've done it slightly different here. They've done future value divided by 1 plus I to the power of n. I've done future value times 1 over 1 plus I to the power of n in my computation earlier. Okay, same thing, okay? Dividing by 1 plus I or 1 plus r to the power of n is the same as multiplying by 1 over 1 plus r to the power of n. Good. Now, the other way, of course, of doing it is using your BA2+. So let's make sure we're happy with this. So what is the present value of $200 to be received in 2 years if the interest rate is 10%? So N is 2 periods, IY 10, future value 200. Now notice they've treated it as an outflow here, 200 minus. Again, if we're receiving 200s, I prefer to do it from the investor's point of view, and I treat it as a positive future value and treat it as plus 200. The only difference is, if I do that, I will get minus 165.29 rather than positive. Let's bring up the BA2 plus and do it. So first things first, second function future value, and then clear equals cancel. I've stripped out all of the data. 2 and N, 2 periods and N, 10, IY. I'm going to do my future value as a positive figure. I prefer that. So I treat inflows to the investor as positives and outflows as negatives. I just find that easier to conceptualize. You can flip it over and treat inflows to the investors as negatives and outflows as positives. It's fine as long as you're consistent. Okay, it really doesn't matter. And now all I've got to do is compute PV, and there you go. There's the 165.29. Lovely. Now, next thing we have to do is look at an annuity. It asks us here, future value of an ordinary annuity. So let's start off with the word annuity. What an annuity is receiving or paying equal cash flows spaced evenly over a period of time. Now, the second phrase you've got there is ordinary. Ordinary means that the first cash flow you pay or receive is at the end of each period. Okay, so in other words, we get the first cash flow at the end of the first period, the second cash flow at the end of the second period, the third cash flow at the end of the third period. The alternative of an ordinary annuity is an annuity due, and this just assumes that the cash flows arise at the start of each year. Okay, we'll look at that in a second. So ordinary annuity, first cash flow paid or received in one period's time. So we've got an ordinary 3-year annuity of $200. So remember, it has to be the same, even cash flow, $200, being either paid or received. Okay, we're looking at payments in this case, and it's asking us what is the future value. So what is the value at T3? Now what we could do, again, we've got an interest rate of 10%. What we could do is just compound each of the cash flows up. So the first cash flow received at T1, we'd need to compound up for one period. So we'd need to multiply that by 1 plus our interest rate as a decimal for 2 periods. The second cash flow would need to be compounded from T2 to T3, so just by 1.1. And the third cash flow arises at T3, so doesn't need any compounding at all. So notice that's what they've done here, taking the first $200, compounded it up at 10% for 2 years, the second $200, compounded it for 1 year, and the third lot of $200 is at T3, so it doesn't need compounding. Sum them together to get 662. The alternative way is to do it on your BA2+. So first of all, you want to check your calculator is in end mode. There are 2 modes, begin mode, end mode. End mode assumes cash flows arise at the end of each year. Begin mode assumes cash flows arise at the beginning of each period. Now your calculator automatically defaults to end mode, okay? Unless you've changed it to begin mode. So we better just check how to see which mode you're in. Can you see above your payment button it says BGN? If you press second function and payment, you'll see end appear on your screen. So my calculator is telling me I'm currently set to assume cash flows arise at the end of each period. Good, that's what I want. But if I did want to change it to assuming cash flows arise at the beginning of each period, you just do second and enter, and notice it says BGN on the screen for begin, and also in the top right hand side you see BGN in very small letters appearing on the calculator to remind you that you've got it set to begin mode. 99% of the computations we're going to be doing in our exam assume cash flows arise at the end of each period. Okay, maybe 99% is a bit strong, but the majority. So I'm going to just change it back. Certainly this computation does. So second and enter again, back to end mode. Lovely. Okay, now I just need to enter my data. Before I do that, second function, future value, to clear out the data. So I've got an annuity of 3 years, 3 and then N, a discount rate of 10, 10 and IY, payments, equal payments of 200. Okay, now, if we're treating them as payments, we're going to be treating them as an outflow from the investor's point of view. So I'll type in a negative, which means when I compute the future value, it will come out as a positive. If I put these $200 in as positives, then the future value on the calculator will come out as a negative, just the way it works. So I type 200 negative and hit the payment button. Now all I need to do is compute future value, and there you go. There's your 662. Right, present value of an ordinary annuity. This one's going to be something we're doing a fair amount of, because when we look at a bond, we typically talk about bonds as being a repayment of par at maturity, in other words, a future value, and coupons that are evenly spaced over the bond's life. So a bond is an annuity and a final payment of par value. Right, okay, so let's make sure we can calculate the present value of an ordinary annuity. In this case, of course, all we'd need to do is take the first cash flow, discount it back one period. Okay, so in other words, multiply the first cash flow by 1 over 1.1. Second cash flow, multiply it by 1 over 1.1 squared. And the third cash flow, multiply it by 1 over 1.1 cubed. And then I could sum the observations and I would have my answer, of course. And that's exactly what they've done here. Okay, so rather than multiplying by 1 over 1 plus r to the n, they've just divided by it. Okay, same thing, absolutely the same thing. I prefer to do 1 over 1 plus r because that's a discount factor, and we encounter discount factors later on in the syllabus. And if you've done it this way all along, you're kind of already familiar of what a discount factor is. Remember, take a future value, multiply by a discount factor, and you get a present value. So the present value of those 3 lots of $200 discounted back one at a time and summed is $497.37. Now, of course, what we want to do is do it on the BA2 plus. So let's have a look at that. Let me bring up my BA2 plus. Here it is. So second function, future value, clear equals cancel. Good. I've stripped out my time value and money buttons and I'm good to go. 3 and N. 10 and IY, 200 and payment. Now again, it does tell me my payments are payments rather than receipts. So really, rather than enter it as a positive number, I could enter it as a positive number. Look, if I do that and do second present value, oh, sorry, pressed the wrong thing there. If I do compute present value, then it gives me minus 497.37. But given their payments, I would be better off saying 200 negative, treat them as outflows, and you press the payment button. Then when I compute my present value, I get a positive value. Okay, so 497.37. Good. Certainly you're going to be doing that on the BA2 Plus calculator. Now here we've got a delayed annuity. So it's an ordinary annuity, but rather than the first payment starting at T1, we've got our first cash flow starting at T3. There's a number of different ways of doing this. First of all, we'll start with the manual way of doing it. Now notice we've got a different discount rate. Our IY is 9% this time rather than 10%. So what we could do is the first cash flow is at T3, so we could take that cash flow discount back 3 periods onwards and upwards. So notice with this cash flow at T6, we could discount that by multiplying it by 1 over, in this case, 1.09 to the power of 6 to get its present value. This cash flow multiplied by 1.09, 1 over 1.09 to the power of 5. This cash flow 1.09 to the power of 4. This cash flow 1.09 to the power of 3. Okay, so discount the cash flows one at a time. Be good and take the future cash flow and multiply by your discount factor, and you could then sum it up and you get 27268. Absolutely fine with you doing it that way, but it is a little time intensive. So we want a quicker way of doing this. So we're going to use the BA2 plus calculator. So let's skip to the next slide. Okay, so present value and ordinary annuity beginning at T equals 1 on the calculator. Now what we're going to do here is a bit of let's pretend. We're going to pretend that T2 is in fact T0. Because then the first cash flow is in 1 period's time. So that then pretend is T1, that becomes T2, that becomes T3, that becomes T4. Oh, beautiful, because now we've just got a simple ordinary annuity and we can work out the present value of that, okay, at T0. We know how to do that already. So we're going to do that on our BA2 plus calculator. Again, just whilst we're getting used to this, I'll bring up my calculator and do it with you. So second function, future value, to clear out your buttons. So we've got a 4-year ordinary annuity. So 4 is N, 9 IY, our payments are 100. I'm going to treat those as outflows, so I'm going to put negative in front of it. And then we can compute our present value. And there you go, you get the 323.97. Now, the next thing, of course, to say is that 323.97 is here at T2. Okay, we were pretending it's T0, but it's not really. It's really T2. So all we then have to do is take that 323.97 and discount it back 2 periods to T0. Okay, so you could do that by 323.97, divide by 1.09 squared, or as I prefer to do it, as I said, 323.97 times 1 over 1.09 squared. I'll do it that way, okay, and we'll just check we get the right answer. And of course, you could do it on the BA2 plus time value money buttons, which again, we will check out just to make sure you're completely comfortable. So let's first of all do it the mathematical way. So 1.09 to the power of 2, y to the x 2, equals 1.881, which of course is a compound factor. To change it into a discount factor, we want 1 over that amount. So hit the 1 to the x button, and our discount factor is 0.84167. Multiply by your future value, 323.97. Press your equals button, and there you go. There's the 272.68. Of course, the alternative was to use the time value money buttons. So second function, future value, and then strip the numbers off the screen. And we could have done 323.97. 323.97 is our future value. 9 is our discount rate. We're going to discount it back from T2 to T0, so 2 periods is N. Okay, compute PV, and again you can see your 272.68. Lovely, so there is the present value of an ordinary annuity. Now, present value of bond cash flows. As I've already touched on, a bond is simply an annuity followed by a final payment, a future value, that's equal to the par value. So we've got a bond here that has a coupon of 70 euros at the end of each year and then pays its face value back in 6 years' time. So we're going to get 70 lots of, we're going to get 6 lots of coupon payments and then a final payment of par value. We've been told that the discount rate here, we're going to refer to that as yield to maturity when we get into fixed income, is 8%. What is the present value of the bond's promised cash flows? So here we are, we've got a 6-year bond. It pays coupons of 70, 70, 70, 70, 70, and 70, and then a final payment of par value. So the coupons are an annuity, and the $1,000 is a future value. And all of this can be done in one go on that BA2 Plus calculator. So notice we want the calculator in N mode because the first coupon we're assuming is at the end of the first year. Okay. And then we're going to tell our calculator N equals, well, we could enter 5, but we're going to get the wrong answer because actually N is the number of periods and it's 6. So let's just change that to the correct figure there. N equals 6, IY equals 8, our discount rate, payment equals 70, future value 1,000, and we're going to compute the present value and get minus 953.77. So let's do that on the BA2 Plus. Let's get my calculator up. So, as usual, second function, future value, stripping out that data from the time value and money buttons. We're good to go. So I'm going to type 6 is equal to N. My discount rate is 8 IY. My payments are annuity of 70, so 70 in payment, that's the coupons. And then there's a final payment of 1,000, which is a future value. I've got all the cash flows now in my calculator. I now need to just press compute present value, and you can see I get the 953.77. And again, a way to interpret this is the bondholder would be willing to pay out $953.77 or 77 euros today in order to receive an annuity of 70 euros for 6 years plus a final payment of 1,000 euros. Right, future value of an annuity due. Remember earlier, we looked at future value of an ordinary annuity, okay? And we got 662. And I'll come back to that in a second because there's a number of different ways of dealing with this. Now, the future value of an annuity due will be, we've got a 3-period annuity due. Now, remember, when we see that phrase annuity, it means equal payments or receipts with equal spacing of them. And when it says due, it means the first cash flow is paid or received at the beginning of each period. Okay, so at the beginning of the first year, beginning of the second year, beginning of the third year. So at T0, T1, T2 here. Okay. So we could compound them up one at a time. In other words, I could take my $200 at T0 and multiply it by interest rate 10% in this question, 1.1 to the power of 3. I could take the $200 paid at T1 and multiply that by 1.1 to the power of 2. And the final cash flow, 200 at the end of year 2, beginning of year T3, I could multiply simply by 1.1. And that's absolutely acceptable in the exam, okay? And if I do that, notice what I get, 72820. But it isn't the only way I can go about doing this. Of course, I could use the BA2 Plus. So, first things first, let's bring up our BA2 Plus and see if we can do this computation. Now, first things first, my calculator assumes that the first, with a 3-year annuity, assumes the first cash flow is at T1, not T0. Remember, it assumes payments at the end of each year. So, I'm going to have to tell it, override that assumption, assume that your cash flow is at the beginning of each year. Do that. Well, first of all, let's strip out the time value money buttons. There we go. Now I need to tell my calculator cash flows are at the beginning of each period, not the end. So I'm going to do second function, okay, and I'm going to hit the payment button. And there's my calculator saying I currently believe cash flows at the end of each period. I'm then going to do second and enter, and that changes my calculator to begin mode. Okay. Notice now when I press clear equals cancel, I can still see BGN in the top right-hand side of my calculator screen, reminding me that I've got it set to assume cash flows arise at the start of each period. Right, I can now enter my data as normal, so I can type 3 and N. I've got 3 payments. I can tell it my interest rate is 10%, so 10, and IY. I can tell it the payments themselves, 200 negative, because they're payments, okay, is 200, minus 200 and payment. Then compute future value, and there you go, 728.20. Okay, now there is an alternative way of doing this, and that's to leave your calculator in end mode. I'm going to change my calculator back to end mode. Okay. And I'm just going to compute future value again. And there's 662. And remember, that's the answer we got with our ordinary annuity. Well, our ordinary annuity assumed that $200 were at T1, T2, T3. So they simply compounded up one less period. So if I take the 662, which is the future value of an ordinary annuity, okay, and then just compound the whole lot up by one extra period, guess what I get? 728.20. So it is up to you how you do this. You can either compound the cash flows one at a time, you can switch your calculator to begin mode and use the time value money buttons, or you can leave your calculator in end mode, realize that everything's been compounded one less period, and just multiply your answer by 1 plus your discount rate. Up to you. Now, what I would say is when using the BA2 Plus calculator, I would automatically switch it back to end mode immediately after doing any calculation like this, because one of the sneaky things that might happen in the exam, and it's not deliberate by the CFA, is you do a computation using begin mode, you then get a number of wordy questions in the exam where you don't need to compute. Then you get another quants question that involves discounting. You forget you've got your calculator in begin mode and you can't get the right answer. Or worse than that, one of the answers they've given you is if you've left the calculator in begin mode. So get into the habit is if you do put it in begin mode, immediately switching it back to end mode at the end of the computation. Good, okay. Present value of an annuity due. Okay, so we've done future value, so we're now going to do present value. And likewise, you know, there are a number of ways of doing this. We could take the first $200 and discount it back one period, so multiply it by 1.10%, still 1.1, and take the second cash flow, discount it by 1.142 periods. And of course, the cash flow at T0 doesn't need to be discounted at all because it's at T0. And then we could sum those cash flows and we get 547.11. Alternatively, we could use our BA2 Plus calculator. So let's do that. Now, of course, to do that, I'd need to put it in begin mode. Second payment, second and enter. I'm in begin mode. Clear my data, second future value. I'm ready to go. So 3 is N, 10 is IY. My payment is 200 negative. And I'm just going to compute PV. And there's the 547.11. Now, of course, the other way of doing it is to leave it in end mode. So I'm going to put myself back into end mode. And we did this earlier with the present value of an ordinary annuity. Now, when I do this, if I do second function present value now, not second function, compute present value. Let's try and press the right button. Remember, when we did the present value of an ordinary annuity, we got 497.37. Now, if I take this 497, what was it? 497. I'm going to bring my BAT Plus back on the screen. 497.37. That was if the cash flows were 200 here, 200 here, 200 here. In other words, we discounted back one extra period with an ordinary annuity. So if I take the present value of my ordinary annuity and multiply it by 1.1, guess what I get? Well, I get the present value of an annuity due. So again, up to you how you want to tackle this kind of question. I have to say I tended to use the BA2 Plus calculator for it, but up to you. Now, present value of a perpetuity. A perpetuity is an infinite annuity. That's all essentially it is. Okay. Now, we've got an infinite annuity with a rate of return of 8%, and we're asked to calculate the present value. Now, you might have noticed on your BA2 Plus, there's no infinite button on here. Okay. Now, you could type, 99999 if you wanted for n, and you get something very, very close to our answer. Okay. But what we're saying is the present value is 4.5 divided by 1.08 divided by 1.08 squared for the second period, 1.08 to the power of 3 for the third period, 1.08 to the power of 4 for the fourth period, onwards and upwards till the Earth stops spinning. Now, how could we do this? Well, as I said, we could cheat and we could enter, 9999 in there. So we could do, let's actually have a go at doing it. I've never done this, but let's see what we get on our BA2 Plus. If we do it, we should get very close to the correct answer. So let me just clear out this calculator and have a go at doing it. The payment is 4.5. N, I'm going to type 99999999999. N. IOI is 8%. 8 is IY. Compute PV. And oh, look at that, 5625. So you get very, very close to the correct answer. In fact, bang on the correct answer here. But really, what we're doing is we're treating this as an infinite annuity. So for an annuity, to get the present value, it is equal to the payments times 1 over n over 1 minus 1 plus r to the power of n. That's the actual annuity formula. I don't really need it for our exam, but that's what the annuity formula is. Okay, so that's what your BA2 Plus essentially was doing when you were using the payment button. Now, when this term here becomes infinite, then this entire bracket becomes equal to 1. So we can ignore it. So we can actually say the present value is equal to the payment times 1 over, did I say n there? Sorry, that was incorrect. I should have said r, 1 over r, our discount rate. 1 over r. Okay. So we end up with payment over 1 over r when we're looking at a perpetuity. So when n is big, the annuity factor essentially, or the bracket, collapses to 1, leaving us with 1 plus r. So we can then do this. So preferred stock, which is preferred stock is a preference share or preferred stock. It pays an infinite series of dividends when the dividend is a fixed value each period. So we can now work out the present value as 450 times 1 over our discount rate. Our discount rate was 8%, so 8% is a decimal, 1 over 0.08. Which of course is the same as saying 450 divided by 0.08. And if we do that, we get the 5625. So don't really mind how you do it, but it's one that I guess you could trick the calculator like we did by typing n is 9999999. You can do it that way and you'll get as near as damn it to the correct answer. But really, we tend to do it by taking the payment and multiplying it by 1 over our discount rate as a decimal. Okay, and 1 over your discount rate, just be aware, sometimes goes to it is referred to as a capitalization factor. Right, present value of a deferred perpetuity. This is the last real one that we're going to see. So we've got a preferred stock. It's paying $4.50 per year forever, beginning in 4 years' time. Okay, and the rate of return is 8%. What is the present value? Well, we're going to deal with it the same way as before. So, what we've got, if you like timelines, we're staying here at T0. And the first cash flow is in 4 years. So our first cash flow is at T4. And then we've got one at T5. And then that's a terrible attempt at writing 5. And it goes onwards and upwards to T infinity. And we've got 450, 450, etc. 450. Okay, now if we pretend we're one period before the first dividend, then we've just got a normal ordinary perpetuity. Okay, so we could work out the value here by pretending essentially this is T0, this is T1, this is T2, this is T infinity. We could work out the value by taking our payment times 1 over R. Okay, in other words, 450 times 1 over 0.08. And that, of course, is 56.25. So that is our value there, 56.25. All we then need to do is discount that back 3 periods at 8%. So 56.25 discounted back 3 periods at 8%. You can either take 56.25 and divide it by 1.08 to the power of 3, or as I like to do, 56.25 times 1 over 1.08 to the power of 3, okay, and get 44.65. And of course, if you liked, you could do it on the BA2 Plus by entering a future value of 56.25, N as 3, and IY as 8.